Did you know that, according to McKinsey, Amazon generates 35% of the revenue and a 29% increase in sales from the recommendation system? Amazon's recommendation system, driven by machine learning, enables quick customer decision-making for the next best offer products by analyzing preferences, ratings, and purchase history, thus enhancing the customer experience and increasing sales and revenue growth. Machine learning is a method where computers learn from data and predict future behavior without explicit programming. In this video, I'll discuss machine learning use cases in marketing starting from: first, the RFM model, that is a traditional approach but with some limitations. Second, how to build propensity model. Finally, the challenges in implementing machine learning in business. Make sure you stick to the end of the video because I'm going to share my own experience of how the propensity model is used to create an impactful credit score model, adding revenue and cost efficiency. So without further ado, let's get started. Before machine learning, the RFM model was a popular qualitative marketing analysis technique based on the recency or last activity, frequency or total transaction orders, and monetary or total transactional value of customer purchases. To implement the RFM model, customers are given scores based on their historical purchases. A score of 1 indicates rare purchases and a long time since the last purchase, therefore, suggesting activation is the best marketing strategy. A score of 4 indicates frequent purchases with a recent purchase and, consequently, a loyalty card is the most suitable marketing strategy. As shown here, the RFM model is a purely qualitative model without statistical models. As a result, it has limitations in predicting future behavior. First, the RFM model is static and does not consider changes in customer behavior over time, which can result in overlooking shifts in customer preferences and needs. Second, it lacks a customer journey and fails to consider quantitative data for different customer demographics such as age, gender, and location. Finally, it neglects business context such as market trends and competitor strategies that can influence customer behavior. Therefore, future events will be purely guessing without modeling. Overall, these limitations hinder the RFM model's effectiveness in predicting future customer behavior and in making informed marketing decisions. In the second part of this video, let's discuss machine learning for the propensity model, especially for credit risk applications. The essential first step in this process involves dividing our dataset into separate training and testing sets. It is common to allocate 65% of the data for training the model, allowing for learning patterns and relationships within the dataset. The remaining 35% of data is held back for testing purposes, enabling to evaluation of the model's performance on unseen data in terms of accuracy and precision. Classification model development on training data generates probability outputs ranging from 0 to 1. These probabilities reflect the likelihood of specific events occurring by taking into account customer journey variables like past purchases, web visits, email clicks, and demographic information. Examples of classification models include decision trees and random forests. A decision tree operates similarly to a flowchart, where questions are asked based on different variables until a desired outcome is achieved. On the image shown, for example, customers who are above 30 years old and have only one child are predicted to receive loan approval. Conversely, if customers are below 30 years old but have a salary greater than $2,500, they are also predicted for loan eligibility. The random forest algorithm is similar to decision trees but includes multiple random samples of decision trees. Each tree makes a prediction and the outcome is determined by averaging these predictions. Random forest works better than decision trees because it reduces overfitting, ranks feature importance, and handles missing values more robustly. Let's analyze a classification model using rank ordering population from credit risk data. The probability value that is from 0 to 1 from each applicant has been transformed into a credit score from 0 to 1,000. We have 1,000 loan applicants from the testing data, accounting for 35% of the original customer population. These applicants will be divided into 10 equal decile groups based on their scores. From each group, we can calculate the loan default rate. The upper cutoff credit score is 780 with a maximum default rate of 6%. The lower cutoff credit score is 300 with a minimum default rate of 45%. Machine learning has the potential to greatly enhance credit scoring and provide substantial business benefits. In a specific case, Out of a total of 10,000 applicants, 4,000 are approved while 6,000 are rejected. Among the approved applicants, 160 individuals have an extremely high probability of defaulting on their loans if a lower cutoff credit score of 300 is to be used. By eliminating these applicants from the monthly operations, significant cost efficiency improvements can be achieved. On the other hand, among the rejected population, there are 600 individuals with a very low likelihood of loan default when using an upper cutoff credit score of 780. Incorporating these 600 applicants into the monthly operations can generate additional revenue for lending businesses. In the final part of this video, let's understand some challenges in implementing machine learning in business. First, handling sensitive personal data responsibly, such as credit card numbers, is a big challenge in machine learning integration into business, where protecting sensitive information becomes very important. A key solution is using strong data protection measures, with encryption as a central part of keeping data confidential. Encryption makes data unreadable to unauthorized people from this example, reducing the risk of access by hackers or data breaches. This commitment to data protection is not only required by regulations but also builds trust with customers, showing that their information is treated carefully. Second, many machine learning models are black box models that lack transparency, making it difficult for non-technical audiences to understand prediction features. This is especially problematic in industries where interpretability and accountability are important. One solution is to use simpler models like decision trees, which provide explanations for feature importance. Complex model like XGBoost can then be used to improve predictive capabilities. Focusing on simplicity, transparency, and interpretability helps stakeholders trust the accuracy and reliability of these models. In conclusion, machine learning plays a significant role in the marketing industry by enhancing decision-making processes through the utilization of algorithms and predictive models. It enables businesses to target specific audiences and tailor marketing strategies, resulting in cost savings and increased revenue. Overall, machine learning provides more valuable solutions compared to traditional method in the RFM model that is based on recency, frequency, and monetary value. However, it is crucial for machine learning to adhere to data regulations and be accurately interpreted for reliable results. Thank you for watching my video. Don't forget to like and subscribe. If you found this video helpful, you might also be interested in exploring my other related videos on predictive marketing analysis and customer lifetime value. Until then, take care.